It's the key. So it says, tell whether the figure is a polygon. If it is a polygon, name it by its number of sides. So A falls under the category. It's a closed figure, got the line segments. So we're going to go with yes for A. And then to name it, we need to know how many sides it has. 1, 2, 3, 4, 5, 6. So it has 6 sides, which means it's a hexagon. Probably not what you picture when you close your eyes and think about hexagon, but that's a hexagon. All right, so then B, it is not closed, so that would be a no. C, yes, and it is a triangle. And then D, again, yes. And it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides, which makes it a dodecagon. Okay. Those of you sitting in here, just stop me if you have a question or if I'm going too fast. Okay. All right, so then next part says, tell whether the polygon is regular or irregular, and tell whether it's convex or concave. So remember, regular means it's equilateral and equiangular. So here, this is equilateral, but it is not equiangular because those angles aren't all congruent. So that means it is irregular. And it is convex. Convex is when all of the vertices are poking out. Okay, you can draw the diagonals on the inside. Concave is when it's caved in. So this is a convex polygon. Sure. Okay, so then B, this again is irregular because even though it's equilateral and these 5 angles are congruent, it's not equiangular because we got these other angles to worry about. So it is irregular. And because it dents in and you can get a diagonal drawn on the outside, that makes this concave. And if it's concave, it can't be regular anyway, so that's kind of a for sure thing there. G, it's equiangular, kind of looks equilateral, but it's not labeled that way, so this is a rectangle, not a square, so that means it is irregular, and it is convex. And then H, it is equilateral, it's also equiangular, so it is a regular polygon. And if it's regular, it has to be convex. Can't be concave, so it's kind of a given there. Okay, we good on all those classifications? Bless you. All right, so then find each measure. Now remember to read these carefully. I want the sum of the interior angles of a convex 11gon, which I can't believe I actually wrote it like that. That really has a name. That would be an undecagon. And you need to know then that n equals 11. So if I want the total number of interior degrees, that's when I use the n minus 2 times 180. So that's going to be 11 minus 2 times 180. Okay. So that's going to be 9 times 180. And then 9 times 180. If we did 10 times 180, again, think through this. 10 times 180 would be 1,800, right? But I didn't want 10 of them. I only wanted 9 of them, so I would subtract 180. So even here, I can subtract 200, get to 1,600, add 20 back, and that gives me 1,620 degrees is my final answer. And since it said sum, I didn't need to divide or anything to make sure we're reading all those words. All right, so then 2 says the sum of the interior angle measures of a convex dodecagon, that means n equals 12. So that's going to be 12 minus 2 times 180. Well, that's 10 times 180, which we've already figured out is 1,800. And that was the sum, so I just leave it as that. Okay, so remember, if I asked for each interior angle measure of a regular dodecagon, after I found this, then I would divide by 12 to find what the measure of each one of them is, but that's not what this is asking. All right, so then the measure of each exterior angle of a regular quadrilateral, that means n equals 4. So to find each, you got to know the total. Remember, exterior angles, that sum is 360 no matter what. So it's just 360 divided by n. So that's just 360 divided by 4, which means each exterior angle is 90 degrees. Which should make sense, because a regular quadrilateral is a square. So that exterior angle will be 90 degrees. Should make sense to you. All right, so 4 is going to take a little bit more work, because here we want the measure of each interior angle of this hexagon right here. And it's not a regular hexagon, so I can't do the whole divide thing. Before I can find each, I got to know the sum. So I'm going to have to do the n minus 2 times 180. So since it's a hexagon, n equals 6. So 6 minus 2 times 180. It's going to be 4 times 180. So 2 times 180 is 360. Then double that, and you get 720. So 720, that is the sum, total sum in there, which is not what we're asking for. We're asking for each interior angle. So then we have to use that to add all these up. So that's going to give me 8s plus 7s plus 5s plus 8s plus 7s plus 5s equals 720. I got 1, 2, 3, 4, 5, 6. So when I add those, 8 and 7 is 15, plus 5 more is 20. Then I have another 15, so that's 35. Another 5, that's 40. So I get 40s equals 720. So when I divide that, remember what we talked about? You're fine. But I know that s is equal to 720 over 40. Well, the zeros can cancel out. And then half of 72 is 36. Take half again, and I get 18. So s is 18. Still not what it's asking me for, right? So I got to plug it in over here. And I got to do 8 times 18. So I can do 8 times 20, which would be what? 8 times 20 is 160. And then subtract 16, that's going to give me 144. So the 8s is 144. Then 18 times 7. Well, if 8 of them is 144, 7 of them is 18 less. So I can take 10 away and be at 134. Then take another 8 away and be at 126. And 126 over here. And then 5 times 18. I can do 5 times 10, which is 50, 5 times 8, which is 40, add them together, and I get 90 here and 90 here. So then I got to actually answer the question and say that the measure of angle A is equal to the measure of angle D, which is 144 degrees. And then I can say the measure of angle B equals the measure of angle, oh goodness, sorry. Leaning again. Measure of angle B equals measure of angle E, which equals 126 degrees. And then the measure of angle C equals the measure of angle F, which is 90 degrees. So here are my answers. Okay. And then number 5, the wording is like all kinds of messed up. What is the measure of polygon angle RKL? Should be, what is the measure of angle RKL in the polygon? This is what we're looking for here. So I'm looking for the measure of this angle. In order for me to find that, I have to find x. These are exterior angles. So the sum of the exterior angles in any polygon is 360. So I can add 2x plus 3x plus 2 plus 4x minus 18 plus 2x plus 2 equals 360. So then to add my x's, 2x and 3x is 5x, and another 4x is 9x, and then 2x is 11x. And then I got a positive 2 and a negative 18, that'll be a negative 16, and then a positive 2, so it's going to be a negative 14 equals 360. So 11x minus 14 equals 360. Then I'm going to add 14 to both sides, so I get 11x is equal to 374. So 11 goes into 37 3 times with 4 left over, and 11 goes into 44 times. So x is equal to 34. But I'm looking for the measure of angle RKL, so I got to do 2 times 34, which is going to be 68. So the measure of angle RKL equals 68. So then the next one, it doesn't say on all of these to write the postulator theorem, so on the review, if you didn't, that's okay, but you could be asked to do that on the test. So we got to make sure we know what to say and how to say it. So it tells me this is a parallelogram. Good to know. Okay, pay attention to what you're being told. Then I'm going to look for the measure of, or the length of LK. Well, if it's a parallelogram, then opposite sides are congruent. So I can say if it's a parallelogram, then opposite sides are congruent. That's how I know I can set 2y minus 9 equal to y plus 7. Then I solve it, so this is going to give me y equals 16. So then when I'm looking for the length of LK, that's going to be 16 plus 7, which is 23. So the length of LK is 23. Then I also need to find the measure of angle M. These are consecutive angles, and in a parallelogram, so if I have a parallelogram, then I know that the consecutive angles are supplementary. So 3x plus x plus 4 has to equal 180. So this is 4x plus 4 equals 180. So 4x equals 176. 4 goes into 17 4 times with 1 left over, and then 4 goes into 16 4 times. So x is 44. I'm not looking for x though. Got to plug it back in to, I want angle M, which is this one. So it's going to be 3 times 44. 3 times 40 is 120. 3 times 4 is 12. So this is going to give me 132. So this is 132 degrees. Okay. Do y'all have any questions at this point? We good? All right. So then it says, in this parallelogram, ABCD, the measure of angle ABC, this whole angle right here is 79 degrees. The length of BC is 6, what the heck, I'm not even touching. The length of BC is 62.4, and the length of BD, this whole thing right here, is 75. So there's definitely not room for me to write all the theorems, but I'm going to say them, we're going to talk about them. It may be something you would need to write on the test. So if I'm going to look for the length of BE, right, well, I know that this whole thing is 75. It tells me this is a parallelogram, so BE would be half of it, because if it's a parallelogram, then the diagonals bisect each other. That's how I know that this is just going to be 75 over 2. The length of AD, well, if BC is 62.4, then AD is 62.4, and I know that because if it's a parallelogram, then opposite sides are congruent. C, I'm looking for the length of ED. So ED is also 75 over 2, because again, if it's a parallelogram, then the diagonals bisect each other. Measure of angle CDA, this angle right here, that's opposite of this one. So that's going to be 79 degrees, because if it's a parallelogram, then the opposite angles are congruent. BCD, this angle right here. Well, if this one's 79, then this one right here is going to be 101, because if it is a parallelogram, then the consecutive angles are supplementary. Then when I'm looking for DAB, it's also 101. And here I have two different reasons I could give. I could say if it's a parallelogram, then opposite angles are congruent because I just found this one. Or I could say if it's a parallelogram, then consecutive angles are supplementary because you could use either one there. But that was the first one in that whole thing where I had options as to what I could write. Again, didn't write them all, but those are things that you at least need to be thinking, and you very well may be asked to write on the test. So same thing on 8. I don't think there's going to be a whole lot of room to write a whole bunch of them. We are looking for, okay, so again, it tells me it's a parallelogram. So the length of WX is B plus 6. That's what I'm looking for. I know if it's a parallelogram, then the opposite sides are congruent. So that tells me I can do B plus 6 equals 5B minus 8. So it's going to give me 14 equals 4B. So B is equal to 14 over 4, which is 7 over 2. Okay. So, but I'm looking for WX, so I have to add that 7 halves to 6. So 7 halves plus 6, which is really going to be 12 over 2. It's going to give me 19 over 2. So the length of WX is 19 over 2. My reason would be, if it's a parallelogram, then the opposite sides are congruent. That's what allowed me to set it up initially. Then the length of YZ, well, it's just 19 over 2 for the same reason. If it's a parallelogram, then the opposite sides are congruent, and I don't have to really do any work. Angle W, that's this angle right here. These two angles are consecutive, so they're supplementary. So 6A plus 14A has to equal 180. So if it's a parallelogram, then consecutive angles are supplementary. This is going to give me 20A equals 180. So A is equal to 9. But I'm looking for angle W, so I've got to do 6 times 9. 6 times 9 is 54. So the measure of angle W is 54 degrees. And my reason from the beginning would have been, if it's a parallelogram, the consecutive angles are supplementary. Then the measure of angle X, I can either plug 9 into 14A, or I can take 180 and subtract 54. So if I just take 180 and subtract 54, that's going to give me 126. And my reason there would be, if it's a parallelogram, consecutive angles are supplementary. Y is 54 degrees. You could use one of two things, because we just found that this is 126. So this is 54. You can either say, because if it's a parallelogram, then opposite angles are congruent, or consecutive angles are supplementary. It doesn't matter. And then on Z, this is 126. Because again, if it's a parallelogram, either opposite angles are congruent or consecutive angles are supplementary. Okay, everybody okay with all that? All right, so 9 says 3 vertices of parallelogram RSTV are these right here. So R is at negative 8, 2, 4, 6, 8. Negative 8, 1, so this is R. Negative 8, 1. S is at 2, 3, and V is at negative 4, negative 7. Now remember, there's actually 2 different places that we could complete a parallelogram. Oh, wait, maybe I should do that first. I could make it here, like this. Or I could make it up here, but this is called RSTV. So RS, T would have to be somewhere over here, and then V for it to make sense. So I'm going to connect RS, and then I would connect S to T, but I don't know where it is. And then T to V, but again, I don't know where T is. But I can connect these two, at least right here, first. So I'm pretty confident that my other vertex is in quadrant 4. So I want to find the coordinates of the vertex. When I do that, I can find it by counting, but then I have to justify myself a little bit more mathematically. So to get from R to S, I could go up 2 and then over 2, 4, 6, 8, 10. So I'd go up 2 and then over 2, 4, 6, 8, 10. So I feel like that's where T should be, and that is at 1, 2, 3, 4, 5. So this is at 6. Oops. 1, 2, 3, 6, negative 5. Okay. This is where T should be. So when I finish that off, but I have to explain kind of why that works, because I did it by counting, which is fine. That's probably the easiest way to actually come up with it. But for this to actually be the point, then I would need to say, if it's a parallelogram, well, yeah, I could say it a couple different ways. I could just say definition of a parallelogram, or if it's a parallelogram, then opposite sides are parallel. That's the same thing, really. It's just saying you're either saying the definition as a conditional statement, or you can just say the definition of a parallelogram. But we got to actually show that. We got to show that RS, so for RS, I got to find the slope. I also have to find the slope for VT, and those should be the same. And then I'm going to find the slope for RV and ST. Okay. So to start with, slope for RS, delta Y over delta X. I should use a different color. It's going to be 3 minus 1 over 2 minus a negative 8. This is going to give me 2 over 10, which is 1/5, which by itself doesn't mean anything. VT give me negative 5 minus a negative 7 over 6 minus a negative 4. So this is going to give me 2 over 10, which is 1/5. So they are the same. So this shows right here that RS is parallel to VT. So we got the same slope. Then for RV, it's going to give me negative 7 minus 1 over negative 4 minus a negative 8. So negative 7 minus 1 is a negative 8 over negative 4 minus a negative 8 is going to be a positive 4. So this gives me a negative 2. Which again, by itself, doesn't really do anything. So then ST is going to be negative 5 minus 3 over 6 minus 2. So that's negative 8 over 4 again, which gives me negative 2. So this shows that RV is parallel to ST. All right, the number 10 is a show problem, and that's not, I didn't really give you enough room for a show problem, but we're going to show that MNPQ is a parallelogram for A equals 6 and B equals 1.6. All right, so when I'm doing this, I'm thinking all I have is the side lengths, so I'm probably going to have to use the fact that if it's a parallelogram, oh, wait, I want to show, so I don't start with if it's a parallelogram, right? I start with quadrilateral with opposite sides congruent, then it's a parallelogram. That's what I'm trying to show. So I can't start by saying if it's a parallelogram, then the opposite sides are congruent. It doesn't work that way. So I got to find the side lengths here. The length of MN is going to be 2 times 6 plus 5. So that's 12 plus 5, which is 17. And then the length of QP is 4 times 6 minus 7. So that's 24 minus 7, which is 17. So this right here, okay, so we've shown that they both have the same measure, which means I can now say that MN, the length of MN, equals the length of QP, and that is the substitution property of equality. And then I can say line segment MN is congruent to line segment QP, and that's the definition of congruent segments. That's just one set of opposite sides. So I got to do it for the other set of opposite sides also. So MQ. So the length of MQ is equal to 7 times 1.6. Right? So 7 times 15, think about what that is. That'd be an hour, which is 60 minutes. That's 4 15s. 3 more 15s is another 45. So that's 105, right? And then I add 7 more. That would give me 115. But I don't want 115, right? That's not right. What did I do? I did that wrong. Oh, I add 7 more. I'm sorry. It's 105 plus 7 gives me 112, right? I said 115. 112. It's 112. But 7 times 1.6, that's less than 14 because it's less than 2, so that would be 11.2. And then NP is equal to 2 times 1.6 plus 8. So 2 times 1.6, 2 times 16 is 32. So this is 3.2 plus 8 is also 11.2. So I've shown then that MQ, the length of MQ equals the length of NP. That's the substitution property of equality. I promise I'll give you more room to do this right on the test. And then line segment MQ is congruent to line segment NP. And that is the definition of congruent segments. So once all is said and done, you want to make sure that you're trying to show that opposite sides are congruent, and that's what made it a parallelogram. So you went through and showed that that set of sides, opposite sides, is congruent, the other set is congruent, and so you've justified your theorem. All right, so determine if the quadrilateral must be a parallelogram. All right, so there's different ways to show that it's a parallelogram. Opposite sides are congruent, or opposite angles are congruent, or one angle is... We have one set of sides that are congruent, but they're consecutive sides. We have one pair of opposite angles that are congruent. That's not really enough. It's possible that this could be a parallelogram, but it's also possible this could be a kite, so there's not enough information here. So no, I'm not saying it's not one. When it says determine if it must be one, it doesn't necessarily have to be one. We don't have enough information for that. So then when we look at 12, we've got a set of alternate interior angles that are congruent. This is where a lot of people go astray here and try and make the wrong things parallel. If these angles are congruent, like they're telling me, then this, oh my gosh, stay off the board. Then this is my transversal. These are the parallel lines that give me the alternate interior angles congruent. It does not by any means guarantee me that the other ones are congruent. Definitely a possibility, but not a guarantee. So it gives me these sides that are parallel and these sides that are congruent, which does not guarantee a parallelogram because it could be an isosceles trapezoid. We just don't have enough information here, so this is a big no. Now on 13, the diagonals here bisect each other. So yes, and not only can we say yes, and it would be because if the diagonals bisect each other, so if we have a quadrilateral with diagonals that bisect each other, then it is a parallelogram. In addition to that, These diagonals are congruent because all four pieces are congruent. So not only is it a parallelogram, it's a rectangle. That question doesn't ask me that, but just pointing that out for you. All right, so there's two other show problems, which again, you still don't really have enough room for, I know. But we're going to make it work on here. Show that the quadrilateral is a parallelogram for the given variable. State the theorem or definition that supports your answer. All right, so I cannot use opposite angles congruent because I don't have all four angles. It has nothing to do with the sides. It has nothing to do with the diagonals. But there is one that says if one angle is supplementary to both of its consecutive angles, then it's a parallelogram. So if we have a quadrilateral with one angle supplementary to both consecutive angles, then it is a parallelogram. So that's what we have to show, is that that G is supplementary to both of them. So we're just going to start by finding the angle measures. So we'll start with measure of angle A. It's going to be 2 times 27 plus 9. So 2 times 27 is 40. 54 plus 9 is going to be 63 degrees. Measure of angle G is equal to 9 times 13. So 9 times 13 is going to give me, that's 90 and 27, 117. And 117 and 63 gives me 180, so I feel good about my numbers. Measure of angle E is equal to 3 times 27 minus 18, which is also 63 degrees. So what I have here, what I can say is that the measure, here, I know you don't have as much room underneath as I do, but I'm going to write it out here so you can at least read what I'm writing. I know that the measure of angle G plus the measure of angle A equals 117 plus 63, which is 180 degrees. So G is supplementary to A. Then the measure of angle G plus the measure of angle E is equal to 117 plus 63, which is also equal to 180. So I have shown that that G is supplementary to both of them, and that justifies my theorem. So for 15, I can't use the whole consecutive angle thing because I'd only have one consecutive angle. Can't use both pair of opposite sides or anything, but we do have one that says if one pair of opposite sides is parallel and congruent, then it is a parallelogram. So I can show that these are congruent, and then I can also show that they're parallel because of the angles. So if I have a quadrilateral, oh, my computer's being weird again. Quadrilateral with one pair, there we go, opposite sides, parallel and congruent, then it is a parallelogram. So that's my goal, is to show that. So we'll start with the opposite sides. So the length of RS is equal to 5 times 7 minus 10. So that's 35 minus 10, which is 25. The length of QT is 2 times 7 plus 11. So that's 14 plus 11, which is going to give me 25. So I can say that the length of RS equals the length of QT. That's the substitution property of equality. And then line segment RS is congruent to line segment QT. That's the definition of congruent segments. So I've got the opposite sides congruent thing, one pair. So then I got to show that that same pair is parallel. So we got to find the measures of the angles. So measure of angle R is equal to 3 times 25 plus 1. No, put that in the wrong place there, sorry. 3 times 25 plus 1. So that's going to be 76 degrees. Measure of angle Q is equal to 4 times 25 plus 4. So that's 104. So I can say that the measure of angle R plus the measure of angle Q equals 76 plus 104, which is equal to 180. So that shows that they're supplementary. If they're supplementary, then and this is by substitution, by the way, substitution, property of equality. Then I can say that RS is parallel to QT, and my reason is if same side interior angles are supplementary, then two lines are parallel. So, bam, I've showed that opposite sides are parallel and congruent, so I've justified my theorem that I said first up there. Those show problems, there's a lot of writing. All right. So another one, show, but we're going to do this the short way. Show algebraically that the quadrilateral with these vertices is a parallelogram. Okay, so I'm going to start by graphing this. B is at -4, 3. D is at 6, 5. F is at 7, -1. H is at -3, -3. Okay, and then I'm going to connect my dots. So this just says, show that it is a parallelogram. So we got options here. We could say if both pair of opposite sides are parallel, then it's a parallelogram. So I could find 4 slopes. I could say if both pair of opposite sides are congruent, then it's a parallelogram. And I could do distance formula 4 times. I could do one pair of opposite sides parallel and congruent. That'd be one set of slopes and one set of distance. I don't really want to deal with the opposite angles or anything. But if I talk about diagonals, if the diagonals bisect each other, that makes it a parallelogram. So I can use midpoint and would only have to do that twice, and that cuts down on my stuff. So I'm going to say, if I have a quadrilateral with diagonals that bisect each other, then it's a parallelogram. So midpoint of BF, that's going to be -4 plus 7 over 2, 3 plus a -1 over 2. So that's going to be 3/2, and then 1. Then I'm going to find the midpoint of DH. So that's going to be 6 plus a -3 over 2, 5 plus a -3 over 2. So that's again going to be 3/2, 1. So really all that just shows midpoints. You got to clarify this one a little bit and say that they have the same midpoint. Or not they, I don't want to say they. I want to say the diagonals have the same midpoint. So they bisect each other. Right, now again, on some of the rest of these, it doesn't actually say that you have to state the theorems, but you very well may have to on the test. So there's no room to write them, but we'll talk about them, what we would put. In rectangle ABCD, CD is 18. CE is 19.8. I want to find each length. Okay, so when I look for the length of AB, even though this says this is a rectangle, the length of AB is 18. The reason has nothing to do with rectangles. It's a parallelogram property. So if it's a parallelogram, then opposite sides are congruent. That's where that one comes from. The length of AC, all right, well, if this is 19.8, this is 19.8. So to put those two together, that's going to give me 39.6. And my reason for that would be if it's a parallelogram, then the diagonals bisect each other. That's how I know that those pieces would be congruent. So I haven't actually used a rectangle rule yet. Then the length of BD, this right here, is the same as AC because if it's a rectangle, the diagonals are congruent. That's where that one comes from. So this is just 39.6. And then the length of BE is 19.8 because if it's a parallelogram, then the diagonals bisect each other. All right. 18. So this is telling me it's a rhombus. Okay. So WX is 7A plus 1. WZ is 9A minus 6. VZ is 3A. And I want to find all this stuff here. Okay, so I can start off by finding A. That would be helpful. So I can do 7A plus 1 equals 9A minus 6. And I can do that because that's just the definition of a rhombus. If it's a rhombus, it's got 4 congruent sides. So this is going to give me 7 is equal to 2A. So A is 7 over 2. Okay. So that's A. So when I'm looking for WZ, it's going to be 9 times 7 over 2 minus 6. So let me find a place to write that down. So I'm going to do 9 times 7 over 2 minus 6. So 9 times 7 is 63, so this is going to give me 63 over 2 minus 6. I need a common denominator, so this is going to be 12 over 2. That gives me 51 over 2. So WZ is 51 over 2. Then XY is 51 over 2, because if it's a rhombus, all 4 sides are congruent. The length of XV, well, if it's a parallelogram, then the diagonals bisect each other. If this is 3A, this is 3A. So that's going to be 3 times 7 over 2, which is going to give me 21 over 2. And XZ, the whole thing, is going to give me just 21. Because again, if it's a parallelogram, then the diagonals bisect each other. Okay with all those numbers? Good. All right, so then 19. In rhombus RSTV, so again, we know it's a rhombus, measured angle TZV, this one right here, is 8N plus 18. SRV, this whole thing here, is 9N plus 1. So, and then I want to find all this stuff. Okay, so this whole angle here and this one right here are not directly related to each other. However, if it is a rhombus, then the diagonals are perpendicular, which tells me that this is a right angle. So I can say 8N plus 18 equals 90, which means 8N equals 72, and N, oh goodness, N equals 9. So TRS, this angle right here, I guess I need to find this whole one right here first. So I'm going to take that 9 and I'm going to plug it in right here. So 9 times 9 plus 1, it's going to be 81 plus 1. So this angle, this whole angle right here is 82. So TRS, which is just this piece right here, is going to be 41 degrees, because if it's a rhombus, then the diagonals bisect opposite angles. Then RSV right here, you can use a couple of different reasons to find that. I mean, you can use triangle properties that if this right here is 41, this is 90. So to find this, you're going to get 49. So you could just say that the acute angles of a right triangle are complementary. That's one way to look at that. STV, this whole thing right here, that's going to be the same as this, which is 82 degrees. So if it's a parallelogram, then opposite angles are congruent. And then TVR, this whole thing right here, you can say if it's a parallelogram, then the consecutive angles are supplementary. So that would make this 98 degrees. Okay. All right, so then for number 20, rectangle. Remember this. First thing we know about a rectangle is that we have 4 right angles. Second thing that is important, even though we're talking about angles, is that the diagonals not only are congruent, but they bisect each other, which makes all 4 of these pieces congruent, which gives you isosceles triangle, which is key in figuring some of this stuff out. This goes with that stuff up there. So if this is 33, oh my gosh. If this is 33 right here, then this is 33. I know that for sure. Okay, which means I could then find this angle here. And if this is 33 and this is 90, then 90 minus 33 is going to give me 57. So the measure of angle 1 equals 57 degrees. These two triangles are congruent, so if both of these are 33, then both of these are 33. So I can say that the measure of angle, get back to the measure of angle 2, but I can go ahead and say that the measure of angle 3 is 33 degrees. And if this is 33 and this is 33, then I can find angle 4, because 33 and 33 is 66. Subtract that from 180, and angle 4 is going to give me 114. So the measure of angle 4 is 114. Subtract that from 180, get 66 degrees for angle 2. And then if this is 33, that makes this 57, which makes this 57. So the measure of angle 5 is 57 degrees. All right, so then we're going to use the diagonals now, and the key here, which is not what everybody did on their homework, says use the diagonals. There are different ways to do this. It is specifically telling you to use the diagonals. So we plot these points. A is at negative 8, 2, 4, 6, 8, negative 2. So that's point A, negative 8, negative 2. B is at negative 6, 2, 4, 6, positive 8. 6, 8. B is at negative 6, 8. C, 4, 2, 4, 6. D is at 2, negative 4. All right, so although we're graphing it, the picture doesn't necessarily give us anything here. Okay. All right. So it just says to determine whether a parallelogram with the given vertices is a rectangle, rhombus, or square. And then it leads you through it on the next page. So it says determine if it is a rectangle. If it is a rectangle, then the diagonals are congruent. And so our diagonals here are, oops. Oh goodness, what did I do? I don't even know how to move that. Huh? I am, yes. Okay, sorry, I moved that. That might kind of work. I lost my. There we go. All right, so my diagonals, let me draw them in, are BD and CA. Okay, so BD and CA. So I'm going to look for the length of BD, and that is going to be the distance formula. So for BD, that's going to give me it's going to give me 2 minus a negative 6 squared plus negative 4 minus 8 squared. So 2 minus a negative 6 is 8, so it's going to give me 8 squared plus negative 12 squared. It's going to be the square root of 64 plus 144. So that gives me the square root of 208. So when I do my tree, which I'm going to do sideways now, I guess, I'm going to get 104 and 2. 104 becomes 52 and 2. 52 becomes 26 and 2. And 26 becomes 2 and 13. So that's going to give me 4 times the square root of 13. So the length of BD equals 4 square root of 13, which by itself, BD, doesn't really mean anything. Okay. I got to find the other one as well. So the other diagonal, if that was BD, then it would be AC. So the length of AC, square root of 4 minus a negative 8 squared plus 6 minus a negative 2 squared. So this is going to be the square root of 12 squared plus 8 squared. So this is the square root of 64 plus 144, which is the square root of 208, which we don't have to worry about doing anything crazy with that again. Bye. The length of AC is 4 square root of 13. That's what we know. And what I should have made room for up at the top, I'm going to do it down the side, I guess, right here, is that the length of BD is equal to the length of AC by the substitution property of equality. And then line segment BD is congruent to line segment AC. That's the definition of congruent segments. So then I can say that if you have a quadrilateral with congruent diagonals, then it is a rectangle. It's narrow. So I have determined that it is a rectangle. Now I got to determine if it is a rhombus by finding the slope of the diagonals. So starting with line segment BD, slope is delta y over delta x. So for BD, that's going to give me negative 4 minus 8 over 2 minus a negative 6. It's going to be negative 12 over 8, which is going to give me negative 3 halves. Then for line segment AC, delta y over delta x, that is going to give me 6 minus a negative 2 over 4 minus a negative 8 gives me 8 over 12, which is going to give me 2/3. So what this tells me, since their slopes are negative reciprocals, is that line segment BD is perpendicular to line segment AC. So then I can say that if you have a quadrilateral with perpendicular diagonals, then it is a rhombus. So I have shown then that it is a rhombus. So then I determine if it is a square. And so the answer to that is yes, it is a square. yes, ABCD is a square because it's a rectangle and a rhombus. Dang it. Okay. All right, so then kites. All right, so things we know about a kite. We've got exactly two pair of congruent consecutive sides. We know that the diagonals are perpendicular. We've got exactly one pair of opposite angles congruent. So the non-congruent sides come together to give me the congruent angles. Only one diagonal gets bisected, and it's this one because you got congruent triangles there that can help you. Oops, I have like 3 little things on it. And then these angles get bisected. So this one is congruent to this one, and this one's congruent to this one. All right, so let's see what we've got to figure out here. It tells me that VXY, this one right here is 58, which means that this one is 58 because these little triangles are congruent. ZWX, this whole thing right here is 50 degrees, which means this piece is 25 and this piece is 25 because they get bisected. Okay, so let's see what else we actually need. I'm looking for X, Y, Z. So X, Y, Z is this whole thing right here. Now, these opposite angles here, not congruent because it's these that are congruent. I know that this is a little right triangle. So if this is a right angle here and that's 58, then these two have to be complementary. So 90 minus 58 is going to give me 32 degrees here, which means that this piece is 32 degrees. So the whole thing, X, Y, Z, is going to be 64 degrees. Then ZWV, this angle right here. Well, I've already decided that since the whole thing was 50, that has to be 25, so I already figured that one out. BZW, this one right here. Well, again, this is a right angle, so it's a right triangle, so these two angles here have to be complementary. So 90 minus 25 is 65, so this is 65 degrees. BZW, is that right? BZW, yes, it has to be. Okay, sorry, second guessing myself there for a second. And then WZY, this whole thing, when I add these together, 65 and 58 is going to be 123 degrees. 23. I've got this is a trapezoid because I have exactly one pair of opposite sides parallel. It's an isosceles trapezoid, which tells me these two angles are congruent and these two angles are congruent. And in any trapezoid, the leg angles are supplementary. So I'm looking for the measure of angle R and the measure of angle S. Well, if this is 54, this is 54. So the measure of angle S equals 54 degrees. And then these are supplementary, so 180 minus 54 is going to be 126. Those are my two angles. All right, so to find the length of BZ, here again I have an isosceles trapezoid, okay, which means that I know that the diagonals are congruent. So if I want to find the length of BZ, so I'm going to call this X, so that's something to call it. I know that ZH is 70, and I know that EK, this whole thing here, is 121.6. So in an isosceles trapezoid, the diagonals are congruent, so X plus 70 is equal to 121.6. 6. So if I just subtract 70 from that, x is going to be equal to 51.6, which is not really x, it's the length of BZ. Then in this one, I have a trapezoid. It's not an isosceles trapezoid, but these are the midpoints, so I know that this is the mid-segment. I'm going to call it x. It's parallel to the other sides, and it's half its length. So the mid-segment, which is x, is equal to half of the sum of the bases, 30 plus 67. So that means that's going to give me, that's 30 and 67 is 97, and half of that is going to be 97 over 2. That doesn't divide evenly, so that is x, which is actually the length of M. Then, oops, I'm looking for the length of EQ, so I'm going to call it x. Again, this is a mid-segment, so the rule is the mid-segment, which is 3.1, is equal to half of the sum of the bases, so that's 2.7 plus x. So I could distribute the 1/2, but I'm just going to go ahead and multiply both sides by 2. So this is going to give me 6.2 over here is equal to 2.7 plus x. So then I'm going to subtract 2.7 from both sides. So 6.2 minus 2 is going to be 4.2. Subtract 0.7 more. So that would get me to 3.5, which is actually the length of EQ. Reasonableness of an answer, clearly it has to be more than 3.1. Okay, so then I'm going to find the value of n so that PQXY is isosceles. So if this is isosceles trapezoid, then the base angles are congruent. So that means that I would have to show that 8n squared minus 11 equals 6n squared plus 7. So I'm going to subtract 6n squared. I'm going to get 2n squared equals 18. Let's solve for n. So n squared is equal to 9, which means n is equal to plus or minus 3. Positive and negative works here. So there's actually two answers, a positive 3 and a negative 3. Remember to also use your returned homeworks that have been unlocked in Schoology and your ISN. Know your theorems. So if you have to justify yourself, you know whether you have to say, if it's a parallelogram, then blah, 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 or blah, 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 then it's a parallelogram. Make sure you're doing those in the right order.